So the next topic that we're going to talk about is box plot. Now, if you recall, we can also call these box and whisker plots because we have a box here in the center, and then we have what looks like two whiskers coming out of this side and this side. Now, these whiskers represent fourths of the data. So we're taking the data set, the numbers, and we're breaking them up into fours. So the first quarter, the first fourth, is going to be this line right here. That's 25% of our data is going to fall on that line. The next fourth is going to be from what we call the minimum value, so the lowest number, and then we hit the lower quartile, okay? And we're going to go all the way to the median, and that's the next fourth, the next quartile. So that's 25% more of our data. Now, if you recall, the median is the middle. So we are now in the middle of our number set. Okay, and then the next 25% is from the median to the upper quartile. And then the remaining 25% is from the upper quartile to the maximum range. Now, this box is very important because the box itself holds 50% of your data. And we see that the median is like way over here. So a lot of that 50% of the data falls in this range. Whatever these numbers may be is where a lot of the bulk of our data set is going to fall. And this can tell us a lot about a set of information. It's really useful when trying to compare data or see kind of the spread of your data. So let's look at an example. So let's say that we have a box plot that gives the average number of Instagram likes during Miss Huey's class. So we know that the minimum is going to be about right here. So we're going to say that the minimum is approximately 30 because it's between 20 and 40. It's this line right here. And the maximum, the max number of likes is going to be this line right here. We'll say that's about 125. Now, we don't have an exact number, but we're just estimating or approximating based on the box plot. Now, remember, we want to be able to tell where the first quartile and the third quartile is. So the first quartile is this line right here. This is our Q1. That's what we're going to call it. So that appears to be at 50. And the third quartile, or the upper quartile, we're going to call Q3, is right here at 100. The median, the middle number of our data set, is right about here. We're going to say that's about 75. So this part down here is going to kind of interpret the data a little bit. So 75% of students like at most blank photos per day. So remember that each of these represents 25%. So here we have 25, here we have 25, here we have 25, here we have 25. So if I want 75% of students, this is 50, add another 25. So this is what I'm looking at to get 75% of my students. And I want to see how much they like at most, so those aren't going to go above 100. And then the top 25%, so this is going to be my top 25%, they like between 100 and 120 photos per day. Now there's one other term that I want you to know regarding box plot, and that's what we call interquartile range. So remember I told you that this box is important because it holds 50% of our data? Well, the interquartile range is from Q3 to Q1. We're subtracting those. So remember, Q3 is at 100, and Q1 is at 50. Interquartile range can sometimes be abbreviated to IQR, and this is going to equal 50. So the interquartile range in this case is 50. Now remember, the whole point of this box plot is the average number of Instagram likes. So we can tell that the person that liked the most Instagram photos in Miss Huey's class was about 125. The person that liked the least number of Instagram posts in Miss Huey's class was about 30. Now the median of that, which is, remember, the middle, is about 75. But 75% of her students are going to like at most 100 photos. So there's a lot of Instagramming going on in her class. But this is just kind of a brief overview of box plots. So go ahead and use this to analyze the box plot in the question below.